Although it looks like I might be standing on solid ground, we're actually on a floating ice shelf, and there's an ocean 1,000 meters beneath us. And that ocean is warm, and that can melt the glacier from below. And we're here to understand what is driving that melt, because that melt is causing sea levels to rise back in the UK.
Hello, and welcome to the Ocean News Podcast, an audio series in which we take a deeper dive into the most important stories and biggest headlines from the Oceanographic newsroom. I'm Eva Cahill, the editorial assistant here at Oceanographic, and today's episode takes us to a glacier far, far away. The Thwaites Glacier, to be exact, in Western Antarctica. After an arduous 3-week voyage and then a 3-week wait for flyable conditions, a UK-Korean research team has finally arrived on the so-called Doomsday Glacier, and they are set to collect first-of-its-kind data about how this glacier is melting and what implications this will have on global sea levels. The Thwaites Glacier spans an area equal to the island of Great Britain, or the US state of Florida, and in places it is over 2 kilometres thick. This enormous glacier is also critical for predicting future sea level rise. The volume of ice flowing into the sea from Thwaites and its neighbouring glaciers has more than doubled from the 1990s to the 2010s, and the wider region accounts for 8% of the current rate of global sea rise, which is about 4.6 millimetres a year. If the Thwaites Glacier were to collapse entirely, global sea levels would rise by 65 centimetres. Until now, though, one of the most important regions of the Thwaites Glacier has remained largely unexplored. Conditions are hugely challenging, as the area is heavily crevassed and the landscape is dynamic and fast-moving. The team of researchers will use a hot water drill to drill 1,000 metres through the ice to gather measurements and observe how the ocean is melting the glacier from below. Despite the importance of the research, success in getting onto this region of the glacier was by no means inevitable, and the journey was far from easy. After arriving at the glacier following a 3-week boat journey, the 10-person team had to wait for a weather window to safely set up camp and begin the delicate 60-plus hour drilling process. And the conditions continued to be difficult for this type of fieldwork, as Taff Raymond, polar field guide on the expedition, explains.
We knew this place was quite crevassy, so we needed to find somewhere that was suitable to set up such a big site, southeast to heady site. We're constantly monitoring the area to see if there's any changes. When we flew in for the first recce, we were about 100 metres that way. That was 10 or so days ago. So we're moving pretty rapidly here, so we are facing a lot of challenges.
So why are scientists risking such perilous conditions? And what makes the research so important? Well, once the scientists have drilled the 1 kilometre deep hole, they will collect the first long-term direct measurement of ocean temperature and currents at this location. They will also be able to collect sediment and water samples to learn more about what happened at the Thwaites Glacier in the past and what's happening now. This is the first time hot water drilling has taken place on the main trunk of the Thwaites ice shelf, and importantly, it will provide rapid, real-time data on the way this glacier is interacting with warming seas. Dr. Peter Davis, physical oceanographer at British Antarctic Survey, explains.
So for the first time, the data that we collect from the ocean instruments deployed beneath the ice will be sent back to us in real time once a day. Usually we have to wait up to a year or even 2 years to come back to a location to collect that data, and that really slows down our critical research into what drives melting of Antarctic ice shelves. But this time, the data is going to be coming back live. We're going to have that data arriving in Cambridge each day, and that's going to really turbocharge our research and give us the opportunity to understand what is driving this melt and how this region is going to change in the future.
This data will therefore allow us to make more reliable predictions about how the glacier will change in the future, what's causing it to melt, and crucially, how much it will contribute to sea level rise. It's easy to feel disconnected from the implications of rising sea levels. For many, the impact can feel distant, or at least geographically far away. But ongoing sea level rise will have profound consequences for hundreds of millions of people living along the world's coastlines, from Bangladesh and the low-lying Pacific Islands to major cities like New York and London. Expeditions like this one are increasingly crucial, providing the science needed to better understand what lies ahead, and to help coastal communities plan for a changing future. In a BBC interview this morning, Dr. Peter Davies pushed back on the Thwaites Glacier's uncharitable nickname, since it implies that we have very little power in doing anything about it. Indeed, the Thwaites Glacier may be nicknamed the Doomsday Glacier, but that doesn't mean its future is already written. And this expedition should go some way in informing the science that will guide how we tackle warming oceans and rising sea levels. If you would like to learn more about this story, or other stories related to rising sea levels, subscribe to this podcast or head to the Oceanographic newsroom. This has been the Ocean News Podcast. I've been Eva Cahill. Thank you for listening. With thanks to the British Antarctic Survey team for all additional audio clips in this podcast.